In the last lecture, we talked about the different types of data. Today, we're going to talk about collecting data. In particular, how do you choose who you collect data from? So let's start off with some terminology. Population. Population is just the entire collection of people that we're interested in. Now, when I say population, it doesn't have to be everybody in the entire world. The population of people I'm interested in might just be people in Sacramento. So people in Sacramento will be my population. Pretend I'm interested in knowing the percent of people in Sacramento who have a PlayStation 5. Okay. Now, the big problem in statistics is I can't just go and ask everybody in Sacramento whether they have a PlayStation 5. Right? I don't have the means, the money, the time to go and contact everybody in Sacramento. Right? There's just too many people. So instead of asking everybody in Sacramento, I'm going to ask a smaller sub-collection. And that smaller sub-collection is called a sample. So a sample is really just a smaller sub-collection of the population. Right, so instead of collecting data from everybody, because we can't, we're going to collect data from a smaller sub-collection. Now, what do you do after you get the data? Well, after you have the data, you're going to do some sort of calculation. Right? You're going to maybe calculate the average, or maybe calculate the percent. If you calculate the percent or the average from asking everybody in the population, it's called a parameter. So a parameter is a number. And when I say number, think average or percent. And then there'll be other numbers we can calculate that we'll talk about later on in the class. So it's a number that describes the population. And what I mean by that is that you got the number by asking everybody in the population. Now, if you got the average and percent by asking the smaller sub-collection, then it's called a statistic. So it's a number that describes the sample. In other words, you calculate it by asking a smaller sub-collection. Now, the main theme in statistic is I wish I could find the percent of everybody in Sacramento who have a PlayStation 5. Now, I know I can't go ask everybody, so instead I'm going to ask a smaller sub-collection. And then I'm going to calculate the percent of people in that smaller sub-collection that have a PlayStation 5. And my hope is that if I do things correctly, the number I get here is going to be a good approximation to the number that I want here, and I can't have, right? Because I can't ask everybody. So that's the main theme, one of the main themes in statistics. So now let's take a look at example 1. So determine whether the number is a parameter or a statistic. We're deciding whether the number is calculated by asking everybody, in which case it's called a parameter, or did we get the number by asking a smaller sub-collection, a sample, which would make it a statistic. So part A. Interviews of 100 adults, 18 years of age or older, conducted nationwide, found that 44% could state the minimum age required for the office of the president. The number I'm talking about here is that 44%. And the question is, did I get the 44% by asking everybody in the population or just some of the people, a sub-collection? Now, the population I care about here, and the hint is, look at the phrase that comes after the number here, adults 18 years of age or older. Okay, so I care about adults 18 years of age or older. And the question is, did I get this 44% by asking every adult 18 years of age, 18 years of age or older, or did I get that by asking a smaller subcollection, a sample? Well, I asked 100 adults. Right, that's definitely not everybody. So this is a sample, and because it's a sample, this would be a statistic. Part B. Only 12 men have walked on the moon. The average time these men spent on the moon was 43.92 hours. The number I care about here is that 43.92. And the question is, again, did I get this number by asking everybody in the population, or did I get this number by asking a sample, a smaller subcollection? So the population I care about here is what? Okay, look at the phrase after that 12. Men who have walked on the moon. Okay, the population I care about is men who have walked on the moon. And the question is, did I get this number by asking every man who has walked on the moon, or a smaller subcollection? Well, there's only 12 of them, so I probably did get this number by asking all 12, right? So all 12 is the entire population. So this is a population, which means this would be a parameter. Part C. In a national survey of 1,300 high school students, researchers found that the average time spent on Netflix each day was 3.187 hours. We're talking about this number and where we got this from. Did we get this from asking everybody in the population, or did we get this number from a sample? What's the population I care about? Population I care about is, right, the phrase that comes after is number, so high school students. Population is high school students. Did I ask every high school student, or just some of them? I only asked 1,300 of them, right, which is not everybody. So this would be a sample, which would make this a statistic. Part D. Following the 2014 national midterm election, 18% of the governors of the 50 United States were female. Right, number I care about here is the 18%. And question is, did I get this from asking everybody, or did I get this from asking a sample? So what's the population I care about here? This is the governors of the 50 states. So did I get this 18% by asking every governor, all of the governors, or just some of them? Well, there's only 50 of them, so we could have gotten this number by asking all of them, the entire population. Right? There's only 50 of them, and it's pretty easy to go and look up the gender of all 50 governors. So this is probably from a population, which would make this a parameter. We acknowledge that we can't always get data from everybody in the population. So instead of getting data from everybody, we're going to get data from a sample. And the question is, how do you pick the people in your sample? And so what we have here are 6 common ways of picking your sample. The first way is exactly what it sounds like, convenient sample. You're going to pick the people who are most convenient to pick. Say I need to do a survey asking about people's opinions about a certain issue. What I could do is just go to my phone and call up my 10 closest friends, right? Those are the people who are most convenient for me to contact and ask. A voluntary response sample, we're going to set up a mailbox, a website, a phone number. And we open that up to everybody in the population. And then individuals or people self-select or choose for themselves to participate. And so what I'm thinking of in this example is, say, a mailbox at a restaurant, right? On your way out, sometimes you might see a comment box, right? Where you can write down any comments that you have for the business and then put it in the comment box. So this is a comment box at a restaurant. Website, I'm thinking of things like Yelp. Or any review site where the website's set up, it's open to the public, and people choose to go to the website and then write a review, right? Yelp, Rate My Professors. Hopefully you guys didn't use that. Phone number, American Idol. Right, after the show, they give you a phone number, and you call in and vote for your favorite performer. These two methods are generally not good methods to use. And why is that? Well, remember, the overall goal is, the number I really want is the parameter. So this is the number that you get if you were able to ask everybody in the population. You can't have that because you can't ask everybody in the population. So your next option is to ask a smaller subcollection, calculate the number using a smaller subcollection, and your hope is that this number is close to this number, right? And the only way that that's going to happen is if your sample is a good representation of your population. Otherwise, this number is going to be way off from the parameter. These two methods, usually you get samples that are not representative of the population, right? If I just ask my 10 closest friends, right, they're my close friends, so they probably will have the same opinion that I do. And so if I just use that data, then I'm not including people who would have a different opinion than me, right? For a voluntary response sample, the problem with voluntary response samples is that, right, because people choose for themselves to go to these places and offer their opinion, oftentimes the people who choose to participate are the people who either are super happy or super unhappy, right? You don't get a lot of people in the middle. As for, I'll tell you a story. When I first moved out to Sacramento, I didn't know where to move, right? Where to rent an apartment. So I go to apartmentratings.com, and if you go to apartmentratings.com, you're going to see that every apartment in Sacramento has horrible reviews, very bad reviews. And I'm asking myself, what city am I moving to where every single apartment has bad reviews? And this is why. The people who choose to go to the website and write a review either are super happy or super pissed off. Another story. Yelp. I've written 3 reviews on Yelp in my life. All 3 of them are bad reviews, right? All 3 of them were situations where I was very pissed off and I vented by going onto Yelp and writing a review. Both of these methods you should try to avoid if you can, because you oftentimes get samples that aren't representative of the population. So the data that you have and the conclusions that you draw from it probably would not apply to the whole population. Now, the bottom 4 are going to be good ways to pick a sample. So actually, let me go back here. These 2 methods, you'll see in a minute, these 2 methods don't involve any random process. And that distinguishes them from these bottom four because all four of these will involve some sort of random process. And why is that important? Well, that's important because we can't get data from everybody in the population, and because we want our sample to be a good representation of the population, what we want is that everybody in the population has a chance of being in our sample, right? And randomness is going to, it's kind of the best thing that we have to ensure that everybody in the population has a equal chance of being in the sample. The first one here, simple random sample. You're going to use some random process to pick your sample. Okay, so that's the random part of the name. The simple part is you're going to do this without any prior grouping. Now this part might not make sense right now, but it will when I talk about stratified and cluster, because these do involve prior grouping. So what's a simple random sample? So let me give you an example right now. Here we have a population of students. Right? You also have room assignment and year, but don't worry about those right now. We'll talk about those later. For now, just focus on the list of names of students. So that's my population, and what I want to do is pick a simple random sample of 5 students from this population. So the low-tech way of doing a simple random sample is to just write down each student's name on a separate sheet of paper, put it into a box or a hat, shake it up, and then randomly pick out 5 names. These days, with the help of a computer, the way you usually would do a simple random sample is this. I'm going to number everybody in the population. So 1, 2. Okay, I have my population numbered, 1 to 15. And then I'm going to use a computer to help me choose 5 random numbers between 1 and 15. In the upper left here, this is R. So the command in R is sample. And then I want R to pick a number between 1 and 15. And actually, I want R to pick 5 random numbers between 1 and 15. So 1:15 is telling R to pick numbers between 1 and 15, comma, 5, that's telling R to pick 5 numbers. And these are the 5 random numbers. So this is telling me to pick person number 14, which is Laura. Person number 6, Camille. Person number 9, Sarah. Person number 11, Paige. And then person number 8, Julie. And that's how you would typically do a simple random sample in real life. Next up is a systematic sample. So in a systematic sample, it's a 2-step process. You're going to first randomly pick a starting point. And then you're going to pick a starting point, and then you're going to pick every 3rd person or every 5th person. Back to our student example. So let's see how we would pick a systematic sample. So for a systematic sample, you're going to first start by randomly picking a starting point. So we're going to choose to start. And what I need to do is pick one person as my starting point. So in R, I'm going to pick a number, 1:15. So pick a number between 1 and 15, and comma, I want to pick one number. And it says 14. So we're going to start with Laura. And then from there, it says choose a systematic sample of 5 students by choosing every 8th student. So from Laura, I'm going to count 8, and that will tell me my next person. And I want to keep on doing this until I have 5 students total. So starting with Laura, counting 8, I'm going to have to actually go back to the top. So 1, go back to the top, 2, 3, 4, 5, 6, 7, 8. So Tom is next. Okay, count by 8 again. 1, 2, 3, 4, 5, 6, 7, 8. Natalie. Count by 8 again. 1, 2, 3, 4, 5, 6, 7, 8. Julie. And then one more time, starting with Julie. 1, 2, 3, 4, 5, 6, 7, 8. And Linda. Okay, and that's how you pick a systematic sample. So it's important that the first person you pick using some random process. Okay, we don't always want to start with number 1 and then count by 8. And the reason is, remember, the sample, we want to make sure that everybody in the population has an equal chance of being picked. Right? So if you're always starting with number 1, there are people who are never going to get picked. Right? So you want to start off by always using some random process to pick that first person. And then you can start counting. Stratified and cluster sample both start off similar. So they both start off by breaking up the population into groups. And what distinguishes them is what you do after that. So in a stratified sample, after you break up the population into groups, you're going to randomly pick some people from every single group. Okay, and the key point here is that because you're picking some people from every single group, you have a representative from every group. Okay, you have a representative from every group. Now, the typical types of groups that you see here in reality is you may break up the population by gender, by age range, by income, right? Low income, middle income, upper income, by location, north, south, east, west. And the reason is you break up people into these groups because you expect there to be some differences in these groups, right? So that it's important that you include people from every single group in your sample. Now, cluster sample, after you break up the population into groups, you randomly pick some of the groups. Okay, and then you use some or all of the people in those groups that you picked. Okay, the key difference between cluster and stratified here is that you break up the population into groups, you're picking some of the groups, not all of the groups, some of the groups, and then you're only using the people in those groups that you picked. And so because of that, you don't have representatives from every single group. And so for a cluster sample, the groups that you break up your population into, right, you're breaking up people into groups where you don't think there's much difference between the groups. So it's okay that you're not having representatives from every group. So for example, if I wanted to do a survey about the types of cars that students drive at CRC, right? CRC has a bunch of parking lots, right? And so I don't really expect there to be differences between those parking lots, right? So say there's 5 parking lots. And so what I could do is I broke up my population into 5 parking lots. And so what I could do is randomly choose 2 of those parking lots and then just collect my data from those 2 parking lots, right? And then I'm disregarding the other parking lots. And that's okay because I don't expect there to be differences in the parking lots. So it's okay that I'm not including data from the other parking lots in my study. Let's try to do a stratified and a cluster sample on our population of students. So a stratified sample, first thing you need to do is group your population. Break up your population into groups. So it says here, group the students by year and then choose a stratified sample of 6 students. All right, my population, I'm going to break them up by what year they're in. So I have freshmen, sophomore, and juniors here. And I'm going to group them here. Linda is a sophomore. Matt is a sophomore. Okay, so I broke up my population into freshmen, sophomore, and juniors. Now, remember, for a stratified sample, where is it? For a stratified sample, after you break up the population into groups, right, you're going to pick some people from every single group, right? Because you want to make sure that you have representatives from every group. So here, right, I broke up my population into groups, and I want to make sure that I choose some people from every single group. And I want 6 students total, right? So I need to choose 2 students from each group. Okay, so the way I'm going to choose 2 students from each group is the same way we do a simple random sample. I'm going to number the students. And I'm going to choose one student from, actually I'm going to choose 2 students from the freshmen. So which means I need to, in R, choose 2 random numbers between 1 and 5. So I'm going to do sample 1:5, and I want to choose 2 students. Okay, so this is telling me I need to choose student 3 and student 2, which is Julie and Camille. Okay, same thing for sophomores. Okay, number my students. And then I want to choose 2 students from that group. So it's going to be the same thing. Sample 1:5, comma 2. So this is telling me 3 and 5, which is Wyatt and Paige. And then finally, out of my juniors, I'm going to number them and do exactly the same thing. Choose 2 students, or 2 numbers between 1 and 5. 1 and 4, this would be Roy and Laura. And that's my sample of 6 students, and it's stratified because I have representatives from each group. Now, what about a cluster sample? Part D. Group the students by room assignment. Choose a cluster sample of 9 students. Record your final sample below. Okay. So now, for my cluster sample, I'm going to group them by their room assignments. Okay, so room assignments, I have A, B, C, D, and E. Okay, so let me now group them by rooms. Okay, Linda is room A. Matt is room E. Okay, I broke up the population into groups by their room numbers. And then now we're going to do a cluster sample. Okay, so now I'm going to pick some of those groups and then just use the people in those picked groups. I'm going to pick the groups here. So there's 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So this is 1, 2, 3, 4, 5. Okay, I'm going to pick some of those groups. Now, I want a total of 9 students, right? Which means to get a total of 9 students, I'm going to pick 3 of these groups. Okay, so I'm going to pick 3 numbers between 1 and 5. So sample 1:5, and I want 3 numbers, 2, 4, and 5. This is telling me to use groups 2, group 4, and group 5. So my sample is going to be everybody in group 2. So that's Wyatt, Julie, and Paige. Okay, these are all from group B, or room B. 4, which is room D. So this is Roy, Camille, and Ryan, sorry. And these are people in group D, or room D. And then 5, which is Matt, Michael, Mary. And these were all in room E. Okay, that's my sample of 9 students. Okay, notice that I don't have representatives from every single group, right? So in particular, I don't have anybody from room A or room C. But that's okay, because I broke them up by rooms, and I don't expect there to be differences between the rooms. So it's okay that I'm not including rooms A and room C. Whereas in part C, the stratified sample, I broke them up by year, by freshmen, sophomore, and juniors. And because I do think there might be differences between freshmen, sophomores, and juniors, when I pick my sample, I'm choosing stratified because I do want representatives from every single group. Example 2. Identify the kind of sample described. Part A. A college faculty consists of 400 men and 250 women. The college administration wants to draw a sample of 65 faculty members to ask their opinion about a new parking fee. They draw a simple random sample of 40 men and another simple random sample of 25 women. What type of sample is this? Now here's a hint. Just because it says simple random sample doesn't mean that it's a simple random sample. It probably isn't. Okay, so let's go back and look at these descriptions. So the easiest one to pick out, I think, is going to be systematic. So systematic, if it says every 3rd person, every 5th person, then it's systematic. convenience and voluntary response. If the description doesn't involve the word random anywhere, then it's probably going to be either convenience or voluntary response, because those don't involve a random process. Which leaves the hard ones, which are simple random, stratified, and cluster. And what you have to ask yourself is, so what we're interested in is picking the people, right? And the question is, did we break up these people into groups first before we pick them? So if we take a look back here, part A, we're picking people. Did we group them somehow first? And the answer is yes. Okay, we grouped them by men and women. We grouped them by gender. So we are breaking them up into groups. And then the question now is, so it's either going to be stratified or cluster. So now the question is, do we have representatives from every single group? Okay, if we do have representatives from every single group, then it's going to be stratified. If we don't, it's going to be cluster sample. Okay, so here we broke out the population into men and women. Question is, do I have representatives from every group? Yes, right? I have 40 men and I have 25 women. So I do have representatives from every single group, which would make this stratified. Part B, a pollster walks around a busy mall and approaches people passing by to ask them how often they shop at the mall. Okay, so reading that, I don't see mention of any random process anywhere. So this is probably going to be either convenience or voluntary response. Okay, and then if we read it again, this person is just picking people who are just passing by, so picking people who are closest to him or her. So this is convenience. Part C. A pollster obtains a list of all the residential addresses in a certain town and uses a computer random number generator to choose 150 of them. The pollster visits each of the 150 households and interviews all of the adults in each household about their television viewing habits. Okay, so remember, we're picking people. I do see random here, so this is either going to be simple random, systematic, stratified, or cluster. It's not going to be systematic because I didn't see the words every third, every fifth person. So it's either going to be simple random, stratified, or cluster. And the question we should ask is, are these people broken up into groups somehow? And the answer is yes. Okay, they're actually grouped by houses. Inside houses. Okay, so they're grouped by houses. And then now the question is, do we have representatives from every single house, or do we have representatives from only some of those houses? Okay, it says that they picked 150 houses and then went to those houses and interviewed the people in those houses. So 150 houses. Is that every house? No, right? So in a city, there's probably way more houses than 150. So they only chose 150 of them. So they only chose 150 groups and then used the people in those houses or those groups. So we don't have representatives from every single house in a certain town. So this would actually be cluster. Right, so I picked those two examples because one, right, part A, so one way of grouping is by gender, right? But another way of grouping is by inside of a building, right? So we kind of saw this in the student example that we talked about, right? So in one case, we grouped them by what year they're in, and then there was the other example where we grouped them by what room they're in, right? So they're inside of a building, and we're grouping them by what type of building or what type of room they're in. In this case, part C, they're grouped inside of houses. Okay, part D. Police at a sobriety checkpoint pull over every fifth car to determine whether the driver is sober. Right, so I see every fifth. Okay, that's clearly to me that this is going to be systematic. Part E, a television newscaster invites viewers to tweet their opinions on a proposed bill on immigration policy. More than 50,000 people expressed their opinions in this way. Okay, so this is a standard example of you set up a Twitter address, and then that's open to the public, and whoever wants to choose to tweet, they choose to tweet. Right? This is a standard example of a voluntary response. Okay, so for a voluntary response, you set up like a website, email address, a Twitter address in this case, and then you leave it. You don't actively choose who participates, right? The people themselves choose whether they want to participate or not. Part F. The superintendent of a large school district wants to test the effectiveness of a new program designed to improve reading skills among elementary school children. There are 30 schools in the district. The superintendent chooses a simple random sample of 5 schools and institutes the new reading program in those schools. A total of 4,700 children attend these 5 schools. So what type of sample is this? So remember, we're always picking people. The question is, are these people grouped somehow? So they are grouped. They are grouped by what school they go to. Okay, so that's the groups, which would make this either a stratified or a cluster. And now the question is, do we have representatives from every single group, or do we only have representatives from some of those groups? So the group here are the schools. There's 30 schools. Do we have representatives from every single school? No, right? Because the superintendent chose 5 of those schools and then did the reading program in those 5 schools. So we only have representatives from those 5 schools. So we don't have representatives from every single school. And this would be cluster. Part G. All the customers who enter a store on a particular day were given a survey to fill out concerning their opinions of the service at the store. So I don't see any mention of randomness here. So it's either going to be convenience or voluntary response. So which one is it? So I can see this being both of those. So I will accept either convenience or voluntary response. Convenience in the sense that that you're just picking everybody who entered the store, right? So it's convenient for you as the store owner to just choose the people who entered your store. Voluntary response in a sense that, because I'm thinking here, this person gave the form to everybody, and then whoever chooses to come back and put it in a box is part of the survey. So voluntary response in that sense. So it also sounds to me like a comment box type situation. So I'll accept voluntary response also. Part H. 500 people attend a charity event, and each person buys a raffle ticket. The 500 tickets are put in a drum and thoroughly mixed, and 10 of them are drawn. The 10 people whose tickets were drawn win a prize. Okay, so this is a very common example of a simple random sample. So this is like the write people's name on paper, put them in a box, shake it up, and then pull out 5 names, right? So this is something very similar, right? It's describing something very similar. So this is a typical simple random sample. Part I, the director of a hospital chooses at random 100 people from each of the 3 surrounding counties to ask their opinions of a new prescription drug. Okay, so we're picking people. Question here is, are these people grouped somehow? Okay, it does mention 3 surrounding counties. So these people are grouped by counties, right? Surrounding counties. And the question is, do we have representatives from every single group? Okay, assuming that the 3 counties is everybody. So we do have representatives from every single group, right? We have 100 people from each of those groups. So because you do have representatives from every single group, this would be stratified. J, officials at a metropolitan transit authority want to get input from people who use the bus about a possible change in schedule. They choose a simple random sample of 5 buses during a week and poll all the riders on those buses about the change. So we're always picking people here, and the question is, are these people grouped somehow? They are grouped. Okay, they're grouped here by the buses that they're in. Right, so we have the people, they're grouped by buses, and the question is, do we have representatives from every single bus? Or do we have representatives from only some of the buses? So they chose 5 buses, and then they polled people in those buses. There's probably way more buses than 5 buses, right? So we only have representatives from these 5 buses, and there's way more buses in this city. So we don't have representatives from every single bus, which would make this a cluster sample. Okay, a retailer samples 25 receipts from the past week by numbering all the receipts, generating 25 random numbers, and sampling the receipts that correspond to these numbers. So what's described there is exactly what we did here, right? We numbered it, everybody in the population. We used a simple random number generator to pick 5 numbers, and that was an example of a simple random sample. So those are 2 very typical examples of simple random samples. Okay, one, you number everybody in the population, and then you use a computer program to help you choose 5 random numbers, or in this case, 25 random numbers. Okay, that's kind of one typical example of a simple random sample. The other typical one is putting names into a hat, shaking it up, and then picking out 5 names. L. A cell phone company wants to draw a sample of 600 customers to gather opinions about potential new features on upcoming phone models. The company draws a random sample of 200 customers with iPhones, a random sample of 100 from customers with LG phones, a random sample of 100 customers with Samsung, and a random sample of 200 customers with other phones. Okay, we're picking people. Are these people grouped somehow? Yes, they are. They're grouped by the type of phones that they have. And then now the question is, do we have representatives from every single group? Or do we not have representatives from every single group? So what are the groups here? iPhones, LG, Samsung, and then other, right? So that's one group. Okay, those are actually all the groups. We do have representatives from every single group, right? We have 100 iPhones, 100 LG, 100 Samsungs, and then the 200 other, which takes care of everybody else. We do have representatives from every single group, which means this would be, which one is it? Stratified. M, every 3rd day. Okay, I don't really need to read the rest of it. Every 3rd day, a computer network administrator analyzes the computer's network log to check for signs of computer viruses. Every 3rd day. Systematic. N, a smartphone app produces a message requesting customers to click on a link to rate the app. Okay, so the app sends out this link to everybody who owns the app. And then whoever chooses to respond, responds. I would say this is voluntary response. Before we move on, let me clarify one thing. So for these questions, for questions where the answer is convenience sample or voluntary response sample, I can sometimes see the answer being both of them, depending on which way you look at it. Right? So a convenience sample to me is you're taking the easy way out, right? You're just picking the people that's easiest to pick. And it can be argued that a voluntary response sample, where when you're setting up a mailbox, a website, a phone number, you are taking an easy way out, right? Because it's pretty easy to set that up and just wait for people to come in and participate. So for like on a test, if the answer is one of these, I will accept both, okay? Because I can see it both ways depending on how you look at it. Now, the other four though, simple, random, systematic, stratified, and cluster, I do think those are different. And so I do want you to focus on the difference between these four. Now that we know what the different sampling techniques are, the question is, given a situation, which sampling technique is best? So example 3, a pharmaceutical company wants to test a new drug that is designed to provide superior relief from headaches. They want to select a sample of headache sufferers to try the drug. Do you think it's possible to draw a simple random sample of headache sufferers? So the question is, can you do a simple random sample? Yes or no? All right. If we think back on what a simple random sample is, and let's go back to the example with the student population, right, where we did a simple random sample. Right. I said the two typical ways you do a simple random sample is you take everybody's name, put it into a box or a hat, shake it up, and then pick out the people. Okay. Or you number them, and then you use a computer program to help you select like 5 random numbers. In both of those cases, we have to have a list of the names first, right? So in order to do a simple random sample, you have to have a full list of everybody in the population that you care about. Now, that's really the question here. The population I care about here are the headache sufferers. Now, question is it possible for you to get a list of every headache sufferer? That's kind of hard. Right? There's not a list out there of everybody who is a headache sufferer. So if you don't have the list to begin with, you can't really do a simple random sample. Okay, because you need the full list of the population first. So here, I would say it's not possible. Right, because we don't have a list of every individual in the population. And population here are the headache sufferers. So how would you actually do this sample? In this case, because we don't have a list of everybody who is a headache sufferer, what you might have to do here is, put out an ad that says, if you are a headache sufferer, contact us to be part of this study, which is a voluntary response sample. So you might have to go with voluntary response. Once you get all the people, then you start thinking about, okay, of these people, how do I choose the people so that it's going to be representative of the population. Okay, so you might have to go with voluntary response here and then think carefully about how you pick the people who do show up. Example 4. The director of a recreation center at a university wants to sample 100 students to ask them whether they would support an increase in the recreation fees in order to expand the hours that the center is open. Do you think it's possible to draw a simple random sample of students? Okay, so once again, question is it possible to draw a simple random sample of students? Which is the same question we have here. In order to do a simple random sample, you have to have a full list of the population. So in this case, population here is the population of students at this school. And the question is, can we get a list of every student at the school? Yes, right? This is actually pretty easy to do, right? Because at a school, there's probably a list, a roster somewhere of every student at the school, right? You have to register for school, and there's a list somewhere of every student at the school. So in this case, you could do a simple random sample. So this will be a yes. Because it's easily because we can easily find a list of every individual in the population. And in this case, the population we care about here are the students at this university. Whoops. In this case, it's easy, right? On a computer somewhere, there's a list of every student at this university so that we can do a simple random sample. In this case, the population is headache sufferers. There's probably not a list somewhere of every headache sufferer in the population. And that's why that's no. Example 5. Products come off in assembly line at the rate of several hundred per hour. It is desired to sample 10% of them to check whether they meet quality standards. Describe a sampling method that would be appropriate in this situation. So whenever I think of an assembly line, I think of this situation. In that situation, what type of sampling would you do? So convenience and voluntary responses are probably not good ones to do, right? So I said to try to avoid those if you can. Out of the rest, simple random is probably not going to be possible, or it's not going to be good because, right, they're coming off the assembly line. To do a simple random, you have to have the full list to begin with, right? So that would mean that you have to wait until everything is finished and then pick your sample. Stratified and cluster, you would have to group them somehow. And I don't think there's an obvious way to group the products here. So I would probably say what I would do in this situation is pick a starting point and then check every 10th one or every 20th one. And so that would describe a systematic sample. Example 6. A company wants to survey employees regarding their job satisfaction. The researchers divide the employees into groups based on which department they work in: sales, advertising, servicing, manufacturing. Would it be appropriate for researchers to draw a cluster sample or a stratified sample using this grouping? Explain your reasoning. Okay, so the people is what we care about. We broke them up into groups based on the department they work in. And the question is, should we do a cluster sample or should we do a stratified sample? And really the question is, do we want to have representatives from every single group, or are we okay not having representatives from every single group? So in this case, we probably do want representatives from every single group, right? Because sales, advertising, servicing, and manufacturing are probably groups of people that we think might be different. So we probably do want representatives from every single group, in which case I would say we want stratified here. So stratified because we want representatives from every single group. Okay, have a good day, and I will see you next time.